they are very good at monitoring stuff, especially applications and service. Here is a screenshot of the Tivoli monitoring system, and it monitors everything in our internal infrastructure in terms of CPU, memory, disk, requests, and network transactions, and it's very efficient in storing those information. However, people never use that in a way to take decisions. They stored it very well, they monitored very well, but they never use that to efficiently see new values and come up with business decisions. And another example that we are using now recently into the monitoring tribe is the application data. In the past, we didn't monitor, but now with New Relic, we can monitor every single aspect of our internal application in terms of database requests, counts, APDEX score, and so on and so forth. And with those data, we can combine and correlate them in order to detect whether a failure is about to occur or whether we have a bottleneck resource in the application, and how it interferes if it's a server problem or it's application problem, and how the user feel when he or she is accessing the application. And based on these value proposition with the data, for the ones who are not from the monitoring tribe, we have a very promising project called Big Sky. And with Big Sky, we want to predict outage prior to their occurrences. That's our motto. We want to provide solutions, prevent and predict conditions, and we want to every user who have access to see everything he wants to see or she wants to see based on the application under his or her domain. And we combine data from Falcon, PagerDuty, ServiceNow, New Relic, and we are using intelligence, machine learning intelligence, to take this data and predict things. This is the link for if you want to access later on and understand more about the Big Sky. And the Anomaly project is under this major project called Big Sky. And the challenge we faced at the beginning analyzing this data is, first off, into the internal global account, we have a lot of different architectures and topologies. We have mainframe, we have distributed system. Into the distributed system, we have Unix, we have AIX, and also we have a sort of application architecture that differ from each other in terms of pattern and in terms of analysis. And here I'm depicting two different architectures, one for distributed with basic infrastructure metrics, and in the right we have the mainframe. And you can see, like, especially because it's very sophisticated and stable mainframe, even though it's reaching, like you can see here, the CPU usage percentage is reaching almost 100%, but it's not causing any problem because the workload processes inside of the mainframe is very efficient to take one payload to another, LPAR from one LPAR to another, and it's very efficient. It turns out to be very efficient. And if you take just one metric, a specific metric, and say, well, let's specify a threshold for this one. And let's say, for instance, that CPU usage, if it reaches 90%, it's a problem. So I'm going to alert the user, I'm going to alert the technical people because it's probably a problem. And if you do so, you are going to issue a lot of false alerts. Because when you analyze the overall picture and combine multiple metrics, you're not causing any problems because it's reaching more than 90%. That's one of the biggest challenges we have in the infrastructure. We have to have, we gotta have very efficient ways to analyze, couple and analyze all together, all the metrics and correlating them to see whether they actually are causing problems or not. And anomaly detection helps you to identify those spots and combining them to have a pattern recognition afterwards, comparing day by day, month by month, week by week, and month by month.